Welcome to IETF 123 Routing Working Group meeting. Let's go through the agenda and status update. So please note, by participating in IETF, you are agreed to following our process and rules. Please read the documents, the BCPs. They explain how IETF works and how your information, your slides, your participation, your questions are treated and shared. And this meeting is being recorded. Harassment policy, we really would like to keep discussions, friendly. Please state your name and affiliation when you ask question. If you participate in person, please join the queue from the application. Remote, please make sure your audio and video are off. Don't hit bandwidth. That is, sometimes very valuable resource. And use headset if possible. Since no one volunteered to help with notes, we are going to work on notes collaboratively. We've got busy agenda, so please be on time. If you're a presenter, please try to finish within your time. Don't eat into someone else's time. We don't have any RFCs since last IETF, none draft adopted since last IETF. We've got TILFA in RFC editor queue. The status of working group documents is in BGP peak. We've booked really good progress, but there's some material work to be done. We've done young doctor review for the VRRP. We are going to last call it after this IETF. We are going to have discussion of point to multi-point, there's point-to-point BFD, and net to cloud problem statement. The authors have requested second working group last call after the draft has been returned. We are still considering what to do with it and further improvement of the document. We requested a directorate review for multi-segment SD1, so waiting. QoS model, I think it's getting really in good shape, and I think it's ready for working group last call, but we will poll the working group. Egress protection on agenda today, and there are a couple of points, whether it belongs here on LSR. I assume our ADs are going to address it. Certain nation routing revive is in good shape. Thanks for working on it. And the address resolution is on agenda today. Question, comments? Okay, we'll start with the presentations. You're going to share it. I don't even have an adapter.
Well, never mind. I will just do the next slide. Used to be something.
Yeah.
Yeah.
Yeah, actually, it should be here. It's not this. This is it.
Hello, everyone. I'm Shu Yang from Shenzhen University, and I would like to present the progress of destination source routing. Next slide. The changelog of this new version is that we added two subsections. One is performing source address selection, and the other is improving source address selection. Next slide. Firstly, I would like to review the long history of this draft. In October 2014, David proposed this draft first, and is originally Homelet related. And in the next year, it became a working group draft. And then in July 2019, the authors asked for the last call in the working group, but it never happened. And the draft then stopped here for a while. But the topic keeps popping up in random places. Then in July 2022, we resubmitted it again. And in the last year, it became the working group draft again. Next slide. We added a new section called source address selection, which indicates that any system implementing destination source routing needs to select a source address for outgoing interface connections with two options. One option is that to install destination source routes with a source prefix of /128. And the other option is use a separate route lookup function. Next slide. And now we have three implementation. The first is 50 implementation is the FutureNet infrastructure in China. And in this implementation, we implemented the forwarding table with a TCAM-based and on barefoot Tofino chips. And in the control plane, we modified the OSPF version 3 to support the destination source routing. And the second version is in OpenWRT. In this version, we support forwarding based on source address in the kernel by default. And in the control plane, it depends on the specific package or version of OpenWRT. And the third version is that Cisco has also implemented a prototype of destination source routing now. Next slide. We have also deployed the destination source routing. In the last year, I mentioned that FITI has deployed 7 destination source routing routers in the last year. But in this year, we have upgraded about 23 destination source routers currently. Besides, for the OpenWRT version, a whole bunch of OEMs shippings are supporting destination source routing now. Next slide. And we would also like to share some of our experiences. First is using scenarios. We are now using destination source routing for load balancing, for multi-homing, and for fast rerouter, and for some security scenarios in China. And we also talk with the network operators of FITI, and then tell us that it has the following advantages. The first is that the source destination routing is quite easy to configure and save a lot of time for configuration. And the second is compared with SR V6, it brings much less header cost. And finally, it brings much less errors or routing loops. Next slide. Okay. And now we feel that is time for the last call in the working group, and we would like to listen to your opinion. Thank you.
David Lamparter, co-author on this. There's one more thing to add from yesterday from the hackathon. We did source address selection testing there. Destination source routing is the only thing that got proper RFC 8028 compliance. If you want to hear about this, come to 6man tomorrow. There will be a presentation about the hackathon.
Eric Ving, Cisco, thank you so much for reviving this. Now, on your slide, you compare source desk routing to SRv6, but I don't see why you're comparing apple with bananas, right? It's a completely different thing.
Maybe we think that these are the two techniques to achieve your policy or to achieve load balancing, but we would like to compare them in the control cost like that. But it doesn't mean that one is much better than the other. Yeah.
Okay.
Any more questions? No. Okay.
Okay. Thank you so much.
It works. It should work now. Yeah, yeah.
Okay. Hello, everyone. I'm Fan Zhang from China Telecom, and I'm presenting the update of Young Data Model for IPv6 neighbor discovery, and on behalf of the other authors. And first, it's a quick recap of what does this draft covers. And this draft covers the Young Data Model for additional configuration and management of IPv6 neighbor discovery and its related functions that are not defined by the IETF IP and IETF IPv6 unicast routing model yet. And this model covers about the IPv6 address resolution, redirect, proxy, NA, and NUD, DAD, send, and the other statistics. We've received comments from the last session and mailing list, so we do the changes in the recent revisions. As for the model name, we change it. In the preview version, we use IETF IPv6 address resolution as the name, and which seems to cause a lot of confusion. And so we changed the name back to IETF ND, and to align with the draft title. And also because that we think it's unnecessary to separate the ND functions into more models, and this draft and we think this draft should cover the rest of the functions that are not defined in the other IETF young models. And also we add notes about the statistics for redirect messages, and considering about there is not much considering that there is not much implementations about the send functions, and there is different implementations across the vendors. So we remove some of its related nodes and to better align with the minimum subset of the vendor configurations. Like we removed the global security ND since it's this work as the same as the CGA flag nodes, and we removed the configurations of nonce and CPA. And that's it. Any comments?
Do you want to comment?
AC Linda Marcus. So when you said recent, this must be very recent because I read this on the plane here, and at that time it was still named address resolution, and you hadn't made, so you made these changes just in the last.
Yeah.
You just uploaded it since Sunday.
I uploaded 2 days ago. I think.
When the window opened back up.
Yeah.
But the one that was available for review didn't have it. I'll have to look at it again. I'm wondering if you could do an analysis of what is it, RFC 4364, is that ND?
Yeah, 4862 and 4861.
62, yeah, 48, 62, and 61. If you could do analysis of what it has, and I know router advertisement is in an old model that I'm on the biz version of, but if there's anything left in the base specification, and then I was thinking about that, now that you put the neighbor undiscovered or anything, probably it does make sense to have it be named IETF ND, as long as you have everything. So I'd like to see what functions from the base ND specification are covered and where they're covered, you know, in the Yang model. Because I think you got most of the stuff now from the base specification in there. You didn't have it before. See, but it sounds like you've made one more revision since the one I reviewed
There's
on
not much.
on Saturday night.
There's not much changes, and it just removed the global secure ND.
And that secure ND is in a separate RFC anyway. It's not part of it, so it's all right. I think it's good not to have that in this model. I think having a model just with the ND, unless it's trivial. I mean, I'm not saying you can't, but I think it's all right to remove that. Yeah. Anyway, that's just my comment. I'll review it again, but it sounds like you moved in the direction. And the only thing I'd like you to add is what you cover and what you don't cover, you know, kind of in the description of the model, like it's usually section 3 or 4 in most Yang model drafts. You put that in there.
Yeah, I think.
Because I was the one who told you it only, back when you only covered address resolution, not to call it ND.
Yeah.
And then you changed it, then you added in the other ND things. So now you're back.
Yeah.
We've come full circle.
There's not much REST function that has to be in another model to power that.
Yeah. No, it's all right to remove send. That's sure. I'm sure. Okay.
Thank you.
I see. I would appreciate your review, and please post it to the list. And I think it's a fair comment before we go towards working group last call.
Ron Bonica, HPE. It might be a little late to make this comment, but has there been any degree of review in 6-man and posting of this draft on 6-man since they own ND?
No, I don't think so.
There probably should be. In fact,
yeah, I think this was just brought to our attention because the history for this draft, because originally we have an up-young draft that's in RTGWG, and the last call, we tried to last call that one, and part of the review comments was to add this part. So we honestly didn't think that much, and then we just thought, you heard AC's comments, so this actually ended up expanding. So originally it was just a small part that we thought, okay, we just go together, right? So it makes sense. And then later it's expanding and split. So it's not reviewed by 6-man yet. This one is relatively new, so it should be reviewed by 6-man.
I totally understand. Since 6-man owns ND, the bigger question is why is it drafted?
Yeah, that makes sense. Yeah, because this was meant to be part of the ARP Young model, and then since it's expanding, we made it a separate draft. So
okay, thank you very much.
We'll take your point. So Eric.
So Eric, I have 2 points. One is the Internet Area Director, and one is an IPv6 person. I really wonder for the chair and the authors why this draft is in this group and not in 6-man. It's within the 6-man remit, and it's not in your charter. You can write young data models linked to routing. There is no routing here. Okay.
Like I explained, this was brought up as part of the ARP Young model. So yeah, when that happened, we didn't think it was gonna be expanding this to this level. So I think it's our fault. We didn't contact 6-man.
It's more than contacting, honestly. It's outside of your charter. So the best way would have been to move this draft and simply rename, right, to 6-man, honestly.
But 6-man doesn't cover the ARP part, right?
I miss what you mean by ARP part.
No.
Oh, ARP, of course not, but there's no ARP there.
No, this one, so there was an ARP Young model, and this was not in the ARP Young model. And then when the ARP Young model was reviewed, part of the major comments is they say you should also cover the IPv6 part. And then when we did that, since it's expanding, we said, okay, maybe we separate them. So it came from the ARP Young model.
Okay, and ARP, I was not involved there. It should have been in INT area working group, most probably ARP, by the way. But this one should really be in 6-man. For instance, like suggested by Ron, every 6-man person would have noticed there are a few things. For instance, like you said, AC, send is not used anywhere, as far as I know, right? It was, I work for Cisco. we get the code, I think we remove it.
Yeah.
Other point, for instance, suggestions, right, for the model. When you say out or in router solicitation, that's very important to differentiate between unicast and multicast. That's very useful for debugging. And I'm not sure whether you capture here the fact that you can receive multiple arrays from multiple routers in this model. So maybe you want to extend it and move it. Talking about the model, not about the location of the work.
So we are open to, you know.
Yeah, I mean, the last part was no more as an AD, like an IPv6 person. This is common to improve the draft.
So let us solicit opinion in 6 months and see what people think.
Yeah, I think that's way better. You will get more review as well. Thank you.
Thank you.
Thank you, Eric. John Linkovic, 6-month chair, hats on. Yes, I'm looking forward seeing that draft in 6-month mailing list. Yeah, I'm not sure we have free time tomorrow, but please send it to the list, and I'm quite sure it will be reviewed because Eric already made some very good comments. Yeah, which should be integrated.
I don't know how 6-month schedule look like. You want them to also present there?
I think agenda is kind of full, but let's talk about that. We have something in time permitting category, but at least it should be definitely sent to the list so a group can take a look at this. We can, at the very least, we can mention it in the chair slides and ask people to pay attention, right? So.
Since this one, because like I said, it started from the RPM model, it meant to be small, but we didn't expect it to be expanding to this level. Maybe now it's right to move to 6 months.
Yes, to be honest, I think ARP and ND shall be separated. I think ND it's way too different from ARP. All right, so maybe it would make sense to have a document focused on ND, which reviewed by 6 men.
So let's talk.
Yeah.
And we'll let you know kind of the conclusion of the discussion, but it seems like moving the ND part to 6 men is pretty obvious. And since working group chairs are willing to take on this work.
Okay. Thanks.
Thank you.
Hello, everyone. I'm Xinxin from China Unicom, and I will present my oral work about the SRv6 parse egress protection. As the abstract states, this document describes protocol extension for faster protecting the egress node and link of segment routing for IPv6 parse. As we know, the TILFA can provide the excellent fast reroute in the SR parse, but it doesn't address the failure of the affecting about the egress node or the egress link to the customer domain. So we do this work to provide the faster protection for the egress node and the link. The progress of the draft is that the first proposed in the March in 2019 and was transferred into a working group document in May 2020. Then many revisions were made based on the experts' opinions. Now it's the version 19 of the WG draft. Sorry, this is a mistake in the slides. Now let's introduce about the core mechanism. First, this draft can provide the SR parse egress node protection. In this topology, we can the main parse is CE to P1 to P1 to PA to C2. So we can provide the backup parse is CE to P1 to P1 to P2 to P2 PB to C2. There is two SR parts. There is the PA is the egress node, and we provide the egress node PB to the fast propagation for the PA. So the PB must advise the information which is represented by PB, PA, and mirror seed. And the P1 as a PAR must pre-compute a repair list toward P2 after receiving the information. So the PB, PA, and the mirror seed indicates that PB protects PA with mirror seed. When the PA failed, P1 detects failure and encaps mirror seed towards packet to P2 via backup path. When the PB receives packet, it maps the local VPN seed and sends the packet to the C2. Also, the draft can provide the SR parts egress link protection. The same in the same topology, the main parts is the same are up, and the back parts is C to P1 to P1 to PA to PB to C2. For the egress link PA to C2, we provide the PB to C2 for the faster protection. So PB must advise the information through the IGP, and in this case, the PLR is PA. So PA must pre-compute a repair list toward PB after receiving the information. When the PA to C2, also the egress link failed, PA detects failure and encaps mirror seed and seed forward the packet to the PB via backup path. So when the PB receives the packet, it may map the local VPN seed and send the packet to the C2. It's the core magazine. So for provide the faster protection, we should do the protocol extension to the IETF and OSPF to add the sub-TLV to advise the information about SRv6 parts egress protection. For the IETF protocol, we add a new IETF SRv6 mirror seed sub-TLV in SRv6 local TLV. The sub-TLV include the SRv6 endpoint function and the mirror seed and sub-TLV. So in this information can advise SRv6 mirror seed and the locators of the nodes to be protected. There is the sub-TLV, and this TLV can carry the locators to be protected by the SRv6 mirror seed. And also we do add a new OSPF SRv6 mirror seed sub-TLV, and also it advises the SRv6 mirror seed and the locators of the nodes to be protected. The same of the sub-TLV can carry the locators to be protected by the SRv6 mirror seed. So now we think the issues has been solved, and we in this work we need to apply the INR assignment, and we are doing this work. Now we think the draft are get ready for the WG next call. Okay, that's all. Any comments?
Jim?
Yeah, Jim Guichard. The first thing that strikes me is, why is this work not in Spring? The second thing that strikes me is, why is the protocol extension not in LSR? And the third, so the question becomes, has this been socialized with Spring and LSR? And if not, why not?
We think their work is about the rewrote. Sorry.
The draft hasn't presented in spring canal.
The draft was presented in spring and LSR working group before.
Okay.
So I think this draft sort of, because RTGWG traditionally has been working on all FR related, protection related issues. So when this draft started, we had a discussion among spring, RTGWG, and LSR. So at that time, I think it was decided to have RTGWG as the home of this draft, but it has been presented everywhere.
Okay, I'm okay with that, except that when you do the working group last call, it needs to be copied to Spring and LSR.
Yes.
As long as I see that when the document comes to me, I'll be okay. But if I don't, then I would return the document. So that's why I'm bringing it up now.
Yeah, we haven't last called this one yet. Yeah.
Okay. All right. Thanks.
Hi, I'm Professor Weinstein. Do you hear me?
Yes, we can hear you. Yeah.
Okay. I have been trying to understand how this draft applies to BGP-based service SIDs, because if you look at the diagrams, can you please show the first network diagram here? And in the slide? No, back. One more. No. It's not about. Yes, this one. From my point of view, the SID that reaches PA, that PA advertises, but this service most probably would be a service SID advertised with BGP in some reasonable address family. And as a consequence, IGP simply wouldn't be aware of any of this SID. It would only be known to P1 because that's how it is advertised. P1, P2, and so on may not be even BGP speakers, basically. So I wonder how this is going, whether this draft is supposed to provide egress node protection for BGP-based services.
Sorry, I'm not sure I hear on your question and try to answer that. The work is to the IGP protocol, and in this topology, P1 is the PLR, and the PEB to advise the information which has the mirror seed. So when the PA failed, the P1 can reroute fast very quickly to the P2, PB, and the 2C2. No. And in this,
how does P1, which is not a BGP speaker, know anything about BGP advertised service SIDs? P1 and PA and PB advertise their service 6 service SIDs to P1 using BGP. P1 and P2 do not even have to be BGP speakers. How is this supposed to work?
No, P1 and P2 between that, then there is no BGP protocol. It is a IGP. They use IGP protocol to advise their information.
I'm sorry, I still don't. Maybe I'm missing something, but I still don't understand how this is. If you say that this is only working with node and adjacency SIDs advertised in IGP, which are advertised in the IGP, this should be explicitly stated in the draft. if you want this draft to be this egress node protection function to be extended to BGP-based services, which from my point of view would be the primary area of interest, then I think that something is missing on the draft. And in addition to what Jim has said, the draft should be also discussed with the best work group, which deals with BGP.
If you could send your questions to the list, that would be highly appreciated. We are running out of time.
Sure,
okay.
No problem at all.
Thank you.
You're welcome.
Thanks.
Okay. Now we are going to start a discussion about BFD and VRRP. So the background is right now we have the problem is to have BFD enabled in VRRP to support fast convergence. Right now we have 2 drafts in the working group trying to solve the same problem with 2 different ideas. So that's why we are having these discussions. We'll have one author from each draft present their idea, mainly focus on the advantage and disadvantage of each solution, and then we'll get the working group opinion how we want to proceed. Okay.
Sure. Can I start?
Yes, please go ahead, and you have control of the slides.
Okay, sure. Thank you. So like the speakers mentioned that we have this issue of how VRRP can be used in the data center, where for the real-time applications, we seldom observe the issues where VRRP takes a lot more time than what the applications expect it to take for the failover. We have looked into various solutions. And there are 2 teams which are present. One is the P2P team, where we brought this draft first with the problem. And then P2MP is another solution, which Greg will be covering. So if you can move to the next. Okay, I have the control. One sec. So like I mentioned, the goal here is how do you integrate BFD for the faster failover for VRRP. As well as with this draft, when we started looking, there are already deployments with VRRP and BFD existing in all vendors. With VRRP having a special case where VRRP master or VRRP active only sends the packet, the master or the active device router doesn't know anything about the backups. So now when a user has to configure it, they end up into having a manual configuration, giving the IP addresses, as well as whenever the failover happens, since we mentioned it's the active router only which sends out the packets, so there is no distinction of the backups. So again, the backups will go for an election and even after implementing the BFD. So there are 2 problems. One, configuration with the current VRRP is a lot more cumbersome. It's a bit of a mess. And then second, when you have to configure it, in all the deployments, we have these mesh kind of configurations for VRRP BFD configurations, because as I told you, the problem is about the backups. So that's where this draft as well as the next draft, both are focused on reduction of this convergence time, which can help us without any aggressive timers being implemented in the VRRP domain. Second, this draft specifically focus on another aspect. As I told, we are configuring those mesh kind of sessions. We want to avoid those mesh kind of BFD sessions because they consume a lot of resources. So this draft is also focused on those 2 aspects. I hope the problem statement is clear. Now coming to this specific draft, what we have brought in this draft is, we brought the concepts where we are saying that there will be a critical backup, for which we have tweaked the state machine of the VRRP. Now this critical backup, why do we really need a critical backup? It will allow us to reduce two things. One, it will allow us to make sure as soon as the failover, as soon as the detection of the BFD link going down is detected by VRRP, it will bring that critical backup into the active state. And you really don't need any master. So the jitter time is gone, as well as it saves the service disruption, which otherwise will happen. More than that, it also focuses on the core idea of the draft by reducing the network overhead. When we talk about network overhead, like we mentioned, the BFD mesh, which was required earlier, now you need only one session, which is between master or active and your critical backup. In order to do that, we have brought a new packet type in this draft, and we are using the existing BFD standards for this. Not just that, if there is already a BFD session established between the nodes, this VRRP can reuse that session. There is no need of creating any newer session. One more point which I want to add, we have seen in the deployments, there are questions which are raised that why do we really need it? There are a lot of deployments since we work on VRRP for all Cisco products. So we know there are a lot of deployments of VRRP where we require more than 2 or 3 backups. So in all those deployments, if you really want a faster failover, this draft, it really helps to reduce those sessions, to reduce the network overhead, which we are unnecessarily adding on this. These are the only points which I wanted to cover. I can hand over to Greg if Greg want to. Okay, AC, you have a question.
AC, you are in queue.
Okay, AC Linda Marcus. Yeah, I finally read both of these drafts on the plane over here. I didn't fall asleep. This first one, I think it has some good ideas, but it's really at the expense of really changing VRRP. And I think I'd like you to put a little more about these use cases where you have more than 2 or 3, like when you have a full mesh. You know, you're talking about like you have a full mesh of, like, let's even say 10. I don't see that. I've only seen deployments of 2 or 3 VRP routers on a single network segment. So, and the other thing I was saying is it seems like people are using BFD without doing this, right? Without doing something like this. They're just either configuring it, or now we have the unsolicited VFD, the session list. So the backups could just say, oh, here's the active, and it could, and they could say, okay, I'm going to form a point-to-point session with them. And if there's only 2 or 3, that's not, you're not really saving that many sessions at the expense of greatly making the protocol much more complex with the backup. Now, on the positive side, I did realize this is kind of like the OSPF concept of a backup designated router. So you have pre-computed if you have, and you don't really have to go through an election. But normally, if you only have a few, the jitter will handle that anyway. So you're really not saving a lot of time because the jitter would handle it. Not the Jira. I see I've been transcribed incorrectly. But anyway, those are the 2 things. So I do see some advantage of it, but I think it's a lot of complexity. And I think if you only have a few, the backups could learn the active and establish a sessionless quickly BFD session. Are you familiar with that BFD, the new one?
Yes, you are talking about
Anki 10 graph. Yeah. Okay.
Yeah. So AC, starting with two questions which you mentioned. Deployments, we can also mention more in the draft if it is required. But in case of data center, in case of enterprise, when we look into deployments, it's mostly 1 or 2 backups. But when we look into data centers, it's usually we have higher number of backups which are required. There are proprietary solutions which talk about 4-way HSRP and others. They are meant only to bring more number of backups. I'm just giving an example why we brought those solutions, because it is in case of data center, that kind of deployments are existing and they are norm. At least we have what we have observed. Coming to your SPFT point, we have gone through it. Even if we use the SPFT, like I mentioned, this draft also brings this concept, like you already touched based on the DR, BDR. I was thinking that I will talk about it, but you answered.
Not seamless BFD, the unsolicited BFD. That's a relatively new draft where you just establish a session, an ad hoc session. You don't need any configuration or anything.
Okay, I haven't checked it. But another aspect of doing this draft was we were looking into the deployments. When I look into P2MP or when I look into unsolicited BFD, I don't know how much implementations they really exist for them. So this draft is also looking from the deployment point of view. If there are those implementations which are available for unsolicited BFD, we can definitely take a look. But I don't know how it will solve the problem of having the less jitter time, because even if it establishes the session, this draft bringing those critical BFD session, it will reduce those. That your unsolicited or SBFD, I am not certain that they can resolve.
I don't disagree that.
Okay, can we move on? Take it to the list, because guys, it's my expense, my time.
You'll have your turn.
Okay.
Yeah, thank you. Oh, next. Okay. Okay, so yes, so there version 3 VRP does allow for sub-second detection using the high rate of VRP messages. But then the question is, so is it something that can be optimized? So do we need to replicate their functionality that already can be done using BFD? And what would be the most suitable BFD mode for VRP environment to do fast conversions? So what we propose is to use not asynchronous point-to-point BFD, because actually their active VRP system is not interested in the state of other backup VRP entities. So only non-active are interested to monitor whether active is performing, and if not, then they can kick in the new election of a new active. So thus, is it responsive? I'm not sure. I cannot make it work.
Can't keep up with your blue screen pace.
Oh, okay. Yeah, now. Okay. Okay, so we want to have what functionality is to have as in VRP RFC. So to have interval of 3 milliseconds, because the timer in VRP is decasecond. And so that gives guaranteed detection in 33 milliseconds. Fine. Okay, the backup routers monitor active router, and active router is not aware of identity of backup routers. So why bother? And then, so from VRP configuration perspective, there are multiple, could be several of them eligible to become active router, depend on a priority. And that can be a dynamic process, because once we already have an active router, VRP system is sticky. So there is no re-election as long as this entity, VRP entity, is up. But at the same time, so that eligibility to become a next active router can change. So there might be some new entity with a higher priority being introduced while we have an active router. So with all these possible scenarios, we evaluated RFC 5880 and 81, which is a single hub BFD for asynchronous mode. So, and whether it's unsolicited or 5881 straight, so they create a state that creates an unnecessary control state on active router. At the same time, it exchanges, it makes the backup router to generate BFD control packets at high rate. So what we look at is that RFC 8562 BFD for multi-point networks. And it's very suitable for VRP, which acts on a single LAN segment. So we don't need to have a special distribution, multicast distribution tree constructed, because that will be the same as sending VRP packets on a LAN. As well as advantage of 8562 that it uses BFD demand mode. So the root of the BFD session, the head, is generating packets. So thus, we reduce the number of BFD control packets crossing this LAN segment. Also, there is no need to do a three-way handshake to establish the BFD session. So their root just starts sending and tails, they listen to it, and they can monitor their state of their point-to-multipoint head. And once they determine that it's down, so basically the normal BFD procedure based on that expiration, so the interval multiplied by the number of missed packets, so they start eligibility. So thus, it's dynamic. So we don't have, in this method, predisposition of predetermining who will be the next eligible active VRP system. So if they just tails in BFD session determine that the current active is down, and then they start a normal VRP process of electing next active. So thus, higher priority can be introduced while we have an acting, performing active system. So with that, it's lighter. So the impact of introducing BFD is lighter because it does not require any state on active creating dynamically or provisioning. It's only advertises its discriminator so that tails can do demultiplexing. So any questions?
AC Linda Marcus. I also read this one on the plane, and I have two very blocking comments. The first is you don't need to gratuitously modify the BFD packets. Given that you're using this encapsulation and you've already configured these routers to use point to multi-point, you can multiplex based on the primary address. And you don't need to modify the BFD packet. You don't need to put that you're using BFD and BFD. You look at all the other protocols. OSPF doesn't, in its hellos, it doesn't have any discriminators, or it doesn't have to do it. You don't have to do that.
I disagree because on the same segment, we can have multiple VRIDs
backing up the same primary address? That's not a very, that's not a, I mean, you
No,
can do
not-
it, but it wouldn't be, you can demultiplex on the primary address that's being backed up. And you've already configured these guys to be in this point to multipoint tree. So you can't say that they don't know that they're running VRRP and using BFD for it.
Well, it would be not as what
It would be not as disruptive on the implementations. I agree that. So we're in agreement there.
No. The thing is that RFC 8562 requires that point to multipoint BFD session being demultiplexed based on the socket information, the source address, and my discriminator. So, but yeah, it's interesting comment.
I mean,
it's yeah. We need to look at
rather than changing VRRP. It would be much better to say that in this case we're deviating and just demultiplexing based on that and take all that unnecessary stuff out. I mean, people who don't implement the protocols always come up with all these complicated encodings.
Yeah,
that's one of my pet peeves of the IETF in general.
Right. Yeah. See, the thing is that this VRP environment is very similar to PIM sparse mode, and in the PIM sparse mode, so we managed to.
I rest my point.
Yeah, we agreed that my discriminator is a useful extension to the protocol, but whether it's sufficient to do demultiplexing of BFD sessions, not using discriminator information from BFD point of view, we need to look at it. It might not be sufficient, the source address.
Yeah, I'd like to see that justification. And assuming you fix that, the other thing is, well, the other draft specifies the changes to the VRP state machine. This doesn't say when you're going to inject where you're going to inject handling, at least handling the event. And I'm hoping you don't add anything to the sending and receiving VRP packets.
No, exactly. So basically, they're detecting that BFD is down, session is down, so it's the same as detecting it from VRP messages.
Well, you have to have a new event.
No, I mean it's the same event.
Okay, then if you're not modifying the state machine, you're not modifying sending and receiving a packet, which implies that you've agreed not to add the discriminator and the flags to the VRP packet then, right? So you're going to take that out.
Well, that again, we need to look at from the BFD point of view, whether it's sufficient to demultiplex BFD sessions, not using discriminator information. But from a VRP state machine, yes, you are correct. So this proposal does not change it because it acts the same as detecting that VRP messages being missed. So basically what it allows to run VRP messages at a much slower rate and enable their fast detection using BFD messages.
Obviously, it's not my call alone to say which of these drafts or both of them go forward, but I'm less opposed to the first one than this one in its current form. I don't think this should go forward in its current form.
Thanks. AC, please also send your comments to the list. Okay, thank you. Sasha, you've got 15 seconds to ask the question. Please go.
I have two very simple questions, actually. What happens if one of the non-active backup routers participating in a given VRP group doesn't support point-to-multipoint BFD? I suspect that that's what means that this router would be overloaded with tons of fast multicast packets that it would receive. It would have to trap them because the destination address, at least by default, is supposed to be the same as used in the VRP address advertisement messages. So the control plane and then the control plane will simply have to respond with destination something like destination unreachable, course unreachable. The second question is, what is supposed to happen to the hosts on the LAN, which for whose benefit VRRP is deployed? Would they also receive this fast flow of point-to-multipoint BFD packets, or would you expect the switches implementing this LAN to not to forward these packets, to be explicitly configured not to forward these packets to hosts attached to them? I think that using of these two questions should be somehow addressed if we are going to use point-to-multipoint BFD. And from my point of view, the main advantage of using one-hop IP BFD, maybe in a non-solicited mode, as already defined, would be much would eliminate all these problems.
Okay, so from Ethernet encapsulation point of view, what we suggest is point-to-multipoint BFD control packets be encapsulated the same way as VRP. So if somebody considers that using VRP v3 at 10 millisecond interval is acceptable, then I wonder why it would not be acceptable to do for point-to-multipoint BFD packets.
But it is my understanding, Greg, that the very idea is to substantially reduce the rate of VRP advertisement packets while still providing fast protection. At least this looks like a worthy goal to pursue from the beginning. Because if you are running, if you are advertising sending a VRP address versus messages at 10 milliseconds, you will have reasonably fast.
Sorry, I'll have to cut you. We are out of time, and we are going to run quick poll on what group thinks about both solutions. And please do send your comments to the list. Greg, thank you.
So we are doing a poll of the working group, the audience. Do you think we should support only one solution? People in the room, please make sure you sign into the Meet ICO session so you can vote for this. You need to sign into Meet ICO so you can see the question and vote for it. Instead of having only one solution, another possible way is we have both of them going experimental. But that's the options we have. But so far, I see people are preferring to have only one solution. I would like this run for 1 more minute. Maybe 30 seconds. Yeah. Well, if you haven't sent into the Meet ICO, please take this opportunity to do it so we also get the right people count. I see we have 133 people in the room. Right now we have 6. About half of the people voted.
The others don't have an opinion.
And that's no opinion counted. So the, yeah. Okay. Yeah, thank you. So we'll go to the next presentation then. So far, we finished all the working group document update. We'll go to the new drafts.
Eventually, we'll start giving prizes to people who send their slides late.
Sorry about this one. I actually learned about slides yesterday night. So Dan Bernier from Bell Canada. I'm presenting on behalf of two other co-authors, Pablo and Clarence from Cisco Systems. The discussion is about doing lightweight host routing using LLDP. So the abstract here is that there are actually already multiple proposals in IETF around how to build DC fabrics. There's a few variations in BGP, SPF. There's work on auto discovery, actually using LLDP as well, work on IGP, and then there's also the L3DL work. They are all in various working group adoption and augmentation. This is not a replacement, it's just maybe an add-on to see what we can do with it. The abstract is also around the focus that most of those solutions has been focused towards the fabric elements, how to build fabrics in a one way, sometimes not really focusing on the full end host and its capabilities or its simplicity. So we assume what does work in a routing element and a network device should be the same as a compute or even some smaller device. So this document actually introduces some extensions to LDP PDU to advertise IPv6 and IPv4 prefix into a new set of TLVs. This is basically to perform a simpler extension for the underlay networking and be able to do it as a really simplest manner for the host environment. Sorry. So a typical use case is, well, we leverage what is massively deployed inside the industry around compute platforms, host device. LLDP is a really well-known protocol used for those kind of environments, both LAN and in some cases just topology awareness. The logic is around the fact it's like relatively native and low complexity on the host. It's done already for a myriad of years, used in other scenarios like VoIP solutions and things like this. So the logic is around you leveraging that same mechanism, LLDP, to advertise underlay reachability, not really doing a full IGP mechanism, basically extending the last host. And you could still use other mechanism like IBGP to advertise NLRIs. The only thing that changes is the way you do the data path learning to get to a device is basically leveraging advertisement from LLDP TLVs. So in a case of a typical scenario, a host would be able to have its own prefix, both v4, v6. You could use it for various overlay mechanisms, VTEPs and VXLAN, Geneve. In our case, of course, we know me, it's not new, it's SRv6 in that location. And basically, the nearest router is able to translate that and redistribute it or introduce it into its IGP. Whether it's the IGP of choice is BGP, GBGP, SPF, or others, or pure ISIS, it's an operator or an implementation specification. And basically, on the networking side, what happens is like from the overlay logic, like the L3 VPN or others, you can still use the same typical control plane mechanism like BGP, but the forwarding path would be purely learned through an LLDP from the end host. So IGP remains at the network element level. You don't necessarily need to extend it too far, but you're still able to reach the device. The reachability to that locator space is either done through the management TLVs done in LLDP, or you could use ARP and the discovery mechanism. That's basically the same thing. The draft introduces new set of TLVs. One which is basically the TLV type and the length that is in the draft. You can read it and explain this, including the prefix blocks. And in later details, you've got the prefix blocks being detailed, where if it's an IPv4, you have do you have a flag to sell it if it's an anycast locator or a prefix, or otherwise if it's just reserved. In a case of E6, you can actually use the same logic, but then you would have like the last bit being able to flag, is it a locator or not, which can, in the case for us, can we be implemented? And when you redistribute into an IGP, you can set the locator TLVs inside ISIS to make it distributed. That's the logic here. On the implementation, oops, sorry, went too far. On the implementation status, existing implementation has already been done with one major well-known vendor. I think the co-authors list will probably tell you it's not a hint. There's already an implemented version in Linux for the LLDPD, and there's upstream work to make it part of the upstream version of LLDPD. Right now, it's running vendor code points, working towards having IETF IANA code points for use. And the next step, we're still going to be updating the draft, one around how could we do LLDP in a different mechanism, like network to host usage of the TLV structure. And then I know it's been a hot burning topic around liveness of LLDP, so we can actually detail a bit more use cases for it, or ways of achieving it. Implementation is also targeted in Sonic workstream. And of course, right now it's requesting working group feedback and or adoption.
David, you are the first one.
David Lamporter. I think this is a really bad idea. I have two specific examples why I think this is a bad idea. The first one is LLDP is specifically designed to bypass STP. You can get LLDP if the port is blocked in STP. You don't discuss that at all in your draft. I guess in the worst case, you have a route that is pointing to a port that is blocked in STP, so that just breaks. It's a fixable problem. The next thing is you say for security considerations that people should use MACsec. The range, or rather the multicast group used to establish the keys and SA for MACsec is not the same as for LDP. In fact, the MACsec one has longer range. That means that you have keys negotiated with another device that is not in fact the same device as is processing LDP. So you need to either run LDP in a non-standard configuration or MACsec in a non-standard configuration to get keys to use MACsec for this. I think these two things are just symptoms of the larger problem. This is really a mix of layering that doesn't belong with each other. And why is this LLDP? Like, what is the actual reason for putting this in LLDP rather than another place? And I also would want to point out, using LLDP is not the same as using the limited scope multicast addresses in Ethernet. If that's what you want, that is a different question. That doesn't imply you need to use LLDP.
So thank you. You want me to answer now, or do you? Okay.
Yeah, this is Wichan. I think it's a good way. Maybe we have some issues we should solve that, but I think the solution is a good solution. One note is that we have a draft which we have presented last time in Spring Working Group. That is, I think, the similar ways, but dedicated for SRv6. So maybe we can have some discussion on time. We can have some collaboration on that. Thank you.
Perfect. Jeffrey.
Jeff Howes, HPE. So David said everything I wanted to say plus 5 times more. Things that I would add to what David said, and they do need to be answered, especially about the scoping stuff, since we actually went through this exercise for BGP auto discovery as well under layer 2. The back scoping is a big deal for this stuff. Your LLDP is Tony Lee's proverbial dump truck. People love to throw stuff inside of it, and the packets can only be a certain size for LLDP v1. You're going to be pushed to LLDP v2 for this stuff, and you just radically increase that. On top of the fact that default timers would have this timing out in 120 seconds, are we about to see BFD for LLDP static routes?
AC Linda Marcus. I'm not terribly opposed to it, but I think we should be very careful about adding more RIB clients and route types, and especially an L2 protocol installing L3 routes. The other thing is, it seems to me you could use RIP version 2 and just do this without putting it in LDDP, and then you'd have something that's already standardized. You know, you could say, okay, we're taking this reserved field and we're using it for the flags. These are hosts, right? That are servers?
Yeah.
Why in the hell does the host have an IGP algorithm?
Doesn't need to have an IGP algorithm.
Well, that's a circular argument.
That's exactly
you know what a circular argument is?
That's the point. If you want to be able to just not having to extend every complexity of an IGP or BGP to the host. Just
I mean, you could put that in RIP. You could put that in RIP v2 as well. You know, there's reserved fields you could use for that. But I don't know why a host. Why isn't it? You know, a host isn't doing an SPF. So why is it specifying the algorithm for the advertisement? The other thing about, I don't like this packing thing where all the prefixes are the same length. It just makes things more complicated. And in actuality, I mean, there's some IPv6 where it might save you something, but it's, it doesn't seem like, I don't know what you're trying to save by doing that.
So I don't know how much of them I need to answer in line, but
yeah.
So, okay, do you want to?
The IGP algorithm is the really one. I don't think a host should specify the IGP algorithm.
It's an implementation detail. I think the logic is if you want to do it or not. Same as with the.
And why don't you use RIP to B2? That's
same as the same logic of why using LLDP is basically trying to implement every other protocol stack into something you want to keep simple as much as possible. LLDP is actually quite already used in almost any environment, either for both topology discovery or learning from an infrastructure perspective. So just being able to leverage it instead of trying to jam more stuff into a system, knowing as well the implementation. Easy to automate the way you create LLDPD configs on a working host. Just trying to do the reverse loop of say, I need to have a host discover itself, get BGP to auto-discover, get BGP to advertise its routes, so the network can then finish the fabric design. LLDP does it already quite nicely in some cases. Maybe you don't want to extend it too much to start and replace an IGP, but just to be able to say, I have a subnet that I need to advertise, so I can build something on top. I think it's quite simple to do.
Tony P. Jew HP.
Magenta.
Yeah, so the MACsec is a huge security air gap that you won't be able to close for practical purposes. And otherwise, I saw Glenn stalking the floor. So I hope that IEEE catches you while you L3 truck dumping into L2, and then we see how it goes. Yeah.
So I'll try and answer on the list.
So the first part of your request, feedback, you're getting the feedback.
Yeah.
The number of technical issues with this.
I will keep on that.
And please do continue the discussion because you see significant opposition to progress. Okay?
Perfect.
Thank you.
Changwon, are you there? Okay. Hurry up. We are already running over time. You are using your own time. 3 minutes.
Hello, everyone. I'm Yisung Liu from China Mobile, and today I will introduce this young model of the SRv6 next hop of root. Oh. Sorry, it's not working. Okay, for the background, and RFC 8349 defends the basic building block of the RIB data model, and for the RFC 9403 extend the RIB to support more attributes such as the multiple next hops for the FR and other root metrics. And but in the SRv6 networks, when we use the SRv6 best effort, and for the next hop in the routing management, we use the SRv6 service seed. And when we use the SRv6 policy for the TE, and for the next hop, we use the color and the point, and the end of the SRv6 parse usually use the service seed. And when we configure the static routes for the SRv6, for the SRv6B, we use the remote seed, like the service seed. And when we configure the static routes by the SRv6 policy, we use the color and point and the service seed in the end. So we have the proposal of this new extended new model for SRv6 next hop, and we augment the two parts, one for the static routes, and both for the V4 and V6, and the other for the RIB. A RIB for the route and active routes. And for the configuration information, we define the SRv6 next hop for V4 and V6, and both have the SRv6 T and the B. And for the state, as the same field, and but read only. So that's all. We want seeking interested people involved in this young model. Thank you.
Please also send the request to the list so people read the draft and respond. Okay.
Thank you.
Thank you. Excuse me. Yeah, very quick one.
So there's already a SRv6 Yang base draft in Spring as a working group document for a long time. Some of the work that I think this draft is proposing perhaps can continue in that document. You're mentioning next draft for SRv6 and SRv6 policy. Both of these drafts are already in the Spring working group for the Yang model.
Yeah, in the time interest, please continue your discussion offline. I know there are stuff defined in the SRv6 model. Yeah. Changwon, are you going to present or? Yeah.
Hello, this is Wei Chancheng from China Mobile, and this is a new draft. It's an enhanced ECMP solution for AI cluster. And as you know, AI data center, the traffic model is totally different from the traditional data center, such as it has a very much fewer flows, and each flow is really huge, and the bursty is very huge. So it brings a very big challenge to the load balancing. If we use a traditional ECMP solution, you will meet some issue. And in order to improve the load balancing for AI training network, and we would like to introduce some enhanced solution. And here is a span leaf topology of the AI data center network. And we would like to introduce two kinds of enhanced load balance. One is when the traffic from GPU is relatively balanced, you can use the ingress interface load balancing method to improve the performance. And the second one is when the traffic received by the GPU is relative balanced, we can use the egress group load balancing method to improve the performance. What are that? Let's say the source, the ingress group solution. So let's say this figure, we have 8 ingress link and 4 egress link. So if we use traditional ECMP, such as for the egress link 1, it's possible that 8 flows from the ingress links can be hashed to that link. So it will bring the very serious congestion. But if we group the ingress links as 2 different groups, and we give each ingress link 1 index, index 1, 2, 3, 4. And the same for the group 2, we give the same index 1, 2, 3, 4. And you run the ECMP based on the index. Then you will see the egress link. For each egress link, you can limit the flows less than 2. So that will improve the load balance performance dramatically. We have some test result. It can improve 30% computing efficiency even. So it's very useful. And here we give an example. I think it's very simple way to improve the network performance. And the other solution is egress grouping solution. This is used for if the receiving traffic is balanced, then you can use this kind of solution. The purpose is to distribute the traffic from a different interface to the different ECMP interface. When those designated for the same remote group. So the basic idea is that you can see for the ingress leaf switch, it have several uplink links. So based on ECMP, it can get load balance. But we hope to limit the ECMP numbers. So we will give the subgroups. And then based on the egress leaves notification, it will give some specific routine information such as a group ID or link ID. Then based on those information, ingress leaf can decide the traffic directed to which subgroup. Then you can get good byte load balancing. And we also have done some tests on this way. This way even much better than the ingress group way when you training the MOE based model. So This is the example in the it's very simple, but it's effective. So as we just mentioned, when we use the egress group, we have to advertise the such as a group ID and route ID to the ingress switch. Then we need an extension to the BGP. This is a rough idea. Maybe we need more comments to improve that. That's all. Any questions or comments?
A quick comment. So you're assuming even load distribution on egress, which is true for traditional dense transformer models, which is not true for MOE. I think I would encourage you to look into scenarios where egress load is uneven and really bursty. How you solve this problem?
Okay, thank you. Okay, any other questions?
Please send an email to the working group list and ask people to read and comment.
Okay, thank you.
Thank you.
Hello, this is Deng Lijie from Chen Telecom. I'm presenting the draft of segment routing based loop frame implementation. What is the micro loop? IP network computes path based on the distributed IGP protocols. If a node or link fails, a loop may occur on the network because LSDBs are not synchronized. However, such a loop disappears after all the devices on the forwarding path complete convergence. Such a transit loop is called micro loop. The document describes some optional implementation methods of segment routing for micro loop avoidance in different scenarios. And the draft divides these scenarios into 4 categories: tangent scenario, cutback scenario, and multi-point scenario, and the multi-source scenario. Next, I will introduce these scenarios and the anti-micro loop schemes. The first one is a tangent scenario. Tangent micro loop refers to the micro loop caused by the node or link failures. And shown in the figure, when the link between router 3 and the router 5 fails, it assumed that router 3 complete convergence first, and router 2 does not complete convergence. There may be a tangent micro loop occur between router 2 and router 3. The anti-micro loop scheme for the tangent scenario consists of 4 steps. Phase 1, a time T1 is configured on the neighboring node of failure and uses the TIFA for warding the traffic. Phase 2, time T2 is configured on the remote node and the node forwards traffic to the neighboring node of failure. Phase 3, time to time out, the remote node returns to the normal convergence in the first leg. Phase 4, the time 1 times out, the neighboring of failure, the neighboring node of failure reverts back to the normal convergence. The second one is cutback scenario. Microloop occur not only when the node or link fail, but also after the failure recovery. And showing the finger, the failure link between router 2 and router 3 is recovered. There may be a cutback microloop occur between router 2 and router 4. It's only necessary to insert and exit from router 2 to router 3, and the path from router 4 to router 6 is granted to be loop-free. Multi-source microloop occur when multiple nodes advertise the same route with the inconsistent convergence space. When IPv4 or IPv6 prefix is advertised by multiple nodes in its domain, the prefix has multiple sources, the router sources. SRv6 multi-source microloop prevention mainly uses an seed and end seed and the neighbor stack for the microloop prevention. And the SRM-MPLS mainly uses prefix seed and adjacent seed and the neighbor stack for the microloop prevention. The next one is a multi-parameter scenario. Multi-parameter microloop occur when the multiple nodes fail, and showing the finger when the router 5 fails. Router 2 forwards the traffic to the destination node along the path router 1, 2, 3, 4, 7 over the failure convergence. And at the same time, router 4 also fails, and the router 3 convergence and forwards according to the path router 3, 2, 5, 6, 7. The multi-parameter microloop occurs between router 2 and router 3. The anti-microloop scheme for the multi-parameter scenario needed the original node calculate a strict explicit path to the destination node and start timer. After the times out, restore the forwarding path after convergence. We compared the draft with the other microloop prevention technologies. The local convergence delay only overs the forwarding loops on the links between the node to the failure and its neighbors. Forwarding loops may still occur on the links. OFIP describes a machine where the convergence of the network upon a topology change is ordered to prevent transit forwarding loops. But the OFIP machine solves all the transit forwarding loops in a network and the price of introducing complexity in convergence process that may require carefully monitoring by the service provider. Okay, that's all. Thanks.
Sasha, please go ahead with your question.
Just wanted to ask this session, whether you have compared this draft with what is written in RFC 5715, which contains a detailed description of multiple scenarios and multiple microloop avoidance techniques.
Yeah, we compare it with our draft. I think the RFC 5715 it corrects the principle of for the loop free, and our draft describes different scenarios and some optional implementation methods. Okay. I think they are different.
Okay, I'll read the draft and try to understand how detailed this comparison is. Okay, thank you.
Java.
Hi, this is Zafar Cisco System. There's another draft on the same topic. It's a draft by Shandi in RTG.
Ahmed's draft?
Sorry?
Ahmed's U loop?
Yes. Okay. So the reason of some of these things not progressing or taking long is these are all internal behaviors. So do we want to, if we want to, do we really want to document these internal behaviors, node internal behaviors? If yes, then there should be work done within the two drafts, with the two drafts in context or some collaboration or some rehashing of what has been done. That draft went all the way to RTG internal reviews for directorate.
Shusong, you have a question? Please make it brief.
Just some response to Zafar's comments. I think that is the question for the whole working group. And for explanation, this document is just an informational document. So it's yes, it's about the implementation, but we think it's beneficial to have some document about the detailed implementation for this topic.
AC Linda Marcus. I just have a quick comment that if that other document didn't progress, there's probably a reason, and we don't want to combine it if keep this one progressing, if we do decide to do that. I think so. The question should be whether we want to work on micro loops.
Okay.
Can I start? Okay. Hello, this is Pang Ran from China Unicom. I want to share a topic about use cases, requirements, and framework for implementing lossless techniques in wide area network. Okay, first I will introduce some use cases. There are many use cases about the data transmission, such as high performance computing for scientific research, generic sequencing for timely medical services, and large-scale audio or video data magnification for multimedia content production. And those use cases need to transmit massive data at TB or PB level over long distance effectively and reliably. This transmission needs to guarantee timelines, completing within a specific time window, such as 1 hour or some days. And those data traffic are predictable. In addition, with the growth of distributed AI/LLM training and inference, the demand of lossless transmission and the flow control mechanism have expanded from DCN to 1. I want to emphasize these scenarios. This is 3 typical scenarios we have done field trial in China Unicom. We did the storage and computing separation training field trial in Hangzhou and Jinhua. The storage, the user storage is located in Hangzhou DC, and the computing nodes is in the Jinhua DC. So the user's sensitive data won't be stored by the Jinhua DC. So it will keep the user's data security. And also we did model split learning field trial in Shanghai. It's a kind of distributed inference. We deploy the first and the last layer of the model in the enterprise side. And then the intermediate layer of the model is located in the cloud DC. So we only need to transport the hidden variable in our wide area network. So we also can keep the user security is invisible. Also, we did the PD separation field trial in Shanghai. It's also a kind of distributed inference. We need to transport the KV cache in the one, and it can it comes from the requirements of prefill node, and the decoder node has different requirements of the computing. So we can by distributed the prefill and the decoder node into different places, we can get more better solution. So here is a problem. The traditional transmission protocol like TCP and especially RDMA are adversely affected by packet loss, especially over long distance transmission. We can see from the experimental data, we can see that when the packet loss reach 0.1%, the throughput drop dramatically. Generally, the packet loss rate of IP-pair network in WANs is about between 0.006% to 0.2%. So the load of the WAN continues to rise. And also when we meet the elephant traffic or some macro traffic burst frequency is very high, it's difficult to predict and ensure the packet loss rate under the burst congestion. Maybe some people want to see that maybe we can just use the lossless protocol as what we did in DCN. But unlike the DCN, the lossless data transmission in WAN is confronted with significant challenges, such as large scale with complex topology is much more complex than DCN, and the diverse type of flow, long transmission paths, and long RTT, and so on. So the lossless technologies for data centers such as prior flow control is PFC, and the explicit congestion notification is ECN have problems when it is applied to WAN. For example, the back pressure from PFC, it can lead to head of line blocking, deadlocks, and congestion spreading. It all will degrade the network throughput. And the limitation of the ECN-based congestion control is effectiveness diminished over long distance. It's especially for the prolonged control loops difficult to quickly alleviate congestion. So we think there are three requirements we will meet. The first is we need more fine-grained flow control mechanism for WAN. PFC is based port level feedback. So it will pause or resume specific priority queues and prevent congestion. To improve upon this coarse-grained port-based PFC mechanism, the following enhancements are considered, including change back pressure message transmission from peer physical port to a sub-interface or slice port. Enabling more precise control at the flow, tenants, and other granular levels. Also about to limit flow control to specified paths and slice through SRv6 precise control and current management technology. And provide more intelligent congestion back pressure with granular parameters based on traffic prediction.
You have less than 2 minutes. You
are okay.
Halfway through your slides.
Okay. The requirement two is to implement end-to-end flow control between DCs, between DCN and WANs. Currently, the BFC is deployed in DCN, but we want to achieve end-to-end seamless flow control between DCN and WAN. So the interworking deployment of PFC and fine-grained flow control mechanism is addressed. The required three is the cross-hop congestion back pressure to reduce costs. Because we want to get the ability to of the fine-grained back pressure, but we don't want to upgrade all our network equipments. So we need a cross-hop transmission. So we can greatly simplify the deployment costs. We don't need to upgrade all our network routers. We only need to upgrade the to upgrade the boundary device and a few immediate devices. Here is a draft we proposed in spring. We want to use a new seed, and PFC seed to identify interface in the network and support the back pressure flow control. Because time is limited, we want to tell about the details. And also, we proposed a framework for implementing the lossless technique in one, including the adaptive planning and management of network resource, the use of multi-level network buffers, and fast source rate control notification. For the next steps, we want more comments about our drafts, and we want to move forward the framework and the requirement work in RTGWG. Also, we will propose a new solution for fine-grained flow control with more granular back pressure. Okay, that's all. Thank you.
You are very quick.
Shouldn't this be dealt at layer 4 or application layer with forward error correction?
I think it's not about the application layer. It's some modification between routers and routers.
You want to further complicate our routing equipment to solve a problem that can be solved end to end.
But I think that when we use, when the scenario is about the wide area networking, so it has a big RTT. If you want to solve the problem via the application, it will be a large latency. So maybe it won't work well. If you solve this problem by the routers, it maybe you can achieve a better experience. Yeah.
Let's continue the discussion on the list. Thank you.
Okay.
Shag.
You may also consider .NET. Yeah. So anyway, so we probably won't be able to get to the last two presentations that's scheduled. Apologies to those two presenters. This might be the last one.
Hello, everyone. I'm Xiaohu from China Mobile Cloud. Let's talk about how to extend the fully adapted routing Ethernet to scale up networks. Okay, today, scale-up networks are becoming more and more important for AI training and inference scenarios, especially when the MUE architecture has become a dominant choice. The networks usually consist of multiple network plans, and each GPU has multiple ports and connected to those network plans. The characteristics of the AI traffic is different from the traditional data center traffic, such as low entropy, elephant flows, and burstness. So the static ECMP load balancing is not ideal in this scenario. Adaptive routing has been recognized by the community, including but not limited to UEC, UL as a valid approach for improving the load balancing in such networks. To perform adaptive routing, switches or GPUs need to be aware of the real bandwidth associated with each ECMP route. Adaptive routing using BGP had been designed, was originally designed for scale-up networks where only switches need to support a fair BGP protocol. But since SCAP has similar scenario, so it's better to extend that protocol into SCAP networks. Okay. Here I give example why fair using BGP is needed in this scenario. Here you can see there are multiple network plans. Each consists of a single switch. Of course, it's a single stage class SCAP network. And each GPU will be equipped with multiple pods. And each pod will further be divided into multiple subpods. One or more pods could be attached to a single network plan. To achieve better load balancing, the GPU need to know the bandwidth associated with each network plan. So it can do fine-grained load balancing according to the real bandwidth associated with each route. Here you can see there are no link down issue. It's symmetric network topology, so the GPU will evenly distribute traffic across all network plans. If a single subpod of a pod is down, then the BGP will propagate this information toward the source GPU. Now GPU is acting as a router, since it can use BGP to exchange with attached switches to advertise its own loopback address. When that link down information is propagated to the source route, source GPU, the GPU will adjust the weight associated with each pod. In this way, the weight associated with top pass will be halved. If the whole part is down, then the weight associated with that pass will be set to 0. In this way, the traffic will be evenly distributed over the remaining 3 network plans. There are 2 options for ECMP. One is per flow based ECMP. This is useful in case where ordered package delivery is needed. For example, the GPUs cannot process ordered packet, or some application need strict ordered packet delivery. In this case, at least one RDMA queue pair per subport need to be established between a pair of GPUs, so as to evenly distribute traffic across all plans. In this use case, switches need to perform per flow load balancing so as to guarantee ordered packet delivery. The second approach is per packet weighted load balancing. This is recommended if disordered packet delivery is possible. In this usage, a single QP is enough for a pair of GPUs. And the packet will sprint across all plans. Okay. In this way, switch just sprint packets as well. We have implemented, we are implementing this approach in our 6.4 GPU super node. And In the future, we'll expand the POC into a larger scale shipper node. Oh, that's all.
I have suggestion, comment before we close. So number one, I think I expressed my suggestion also in ADR. As of now, drafts, or both drafts actually have very, very little technical details. They're marketing level documents. If you want to progress them, please update it. Otherwise, it's marketing.
Okay,
right?
okay.
And number two, everything presented here will work without any changes, just with technologies we developed today in ADR being link bandwidth. So it's unclear what's needed on top of what we're already doing.
Yeah, the first step is to establish the BGP-based FAIR in IDR working group. Once it's done, maybe it can be extended to the scale-up networks. My personal opinion is RTGWG is a better place to do this work. Because there's no need to do further modification to protocols, right?
So as presented, it can be addressed with existing IETF technologies as developed in ADR.
Maybe.
Okay. Just make sure you clearly communicate why this is needed and why we should put time in this, okay?
Okay, thank you.
Thank you.
Okay, Jeffrey Zhang, HPE. The word adaptive and the real bandwidth led me to think that it was bandwidth is the available bandwidth in real time. But after your IDR presentation or offline discussion, you clarified that it's not, it's really the port capacity. So now I'm a little bit confused.
Yeah, here I need to clarify that we just use the link bandwidth, not available or remain bandwidth. Okay.
So it's not adaptive, it's not real time.
No, adaptive routing means we can distribute traffic over different passes according to the pass, according to the bandwidth. It doesn't matter whether it's available bandwidth or the link bandwidth.
Okay, if that's what it means, then.
Okay, thank you.
Thanks.
We are already over time, so please continue your discussion offline.
Please do update the drafts. Technical details. Thanks, everyone, and we'll see you soon at 1:24.